All right, let's talk about a fantastic cosmic mystery, a real head-scratcher that's been uncovered by the James Webb Space Telescope. It's a story that's making us question pretty much everything we thought we knew about the universe's very first moments.
So let's just jump right in with a really provocative question. What if the universe's very first galaxies just didn't play by the rules we wrote for them? And look, this isn't just some fun thought experiment. It's the actual puzzle that's keeping astronomers up at night right now.
Okay, so our investigation begins at the very beginning. We're talking about an era called the Cosmic Dawn, when the first light finally pierced through the darkness of the young universe. And the evidence JWST has sent back from this time, well, to put it lightly, it's just plain baffling. This right here shows you the heart of the problem. On the left, that's what all of our best models predicted. Based on decades of research, we expected to find just a handful of faint, little galaxies slowly getting their start. But then, on the right, well, that's what JWST actually found. A sky just packed with galaxies that were bigger, way brighter, and way more numerous than anyone thought was possible. This chart really visualizes what astronomers are calling the overabundance problem. It shows the huge gap between what we predicted and what we're actually seeing. The theoretical models, that's the little bar on the left. The actual observations from JWST, looking back over 13.4 billion years, that's the huge bar on the right. And you can see, the difference isn't small, it's a chasm. But the plot thickens, because, the galaxies themselves are only half the story. The JWST data pointed to a second, closely related puzzle that makes this whole thing even deeper. 50 times. Just let that sink in. That's the other staggering number from the data. It turns out there were about 50 times more faint active galactic nuclei, basically actively feeding supermassive black holes, than we ever expected. So now we've got two big clues: galaxies that are way too bright and black holes that are way too common. So when you're faced with shocking evidence like this, you do what any good detective would do. You round up the usual suspects. And in astrophysics, when you see a bunch of unexpected light, your number one suspect is always stars. So three main theories popped up. First, maybe star formation was just in complete overdrive back then. Galaxies were just hyper-efficient star factories. Second, what if the first generation of stars were all absolute giants, burning incredibly hot and bright? Or third, maybe the extra light wasn't from stars at all, but from the glowing disks around all those new black holes we found, just making the whole galaxy look brighter. But here's the thing. All of these star-based ideas, they slam right into a brick wall. It's called the dust problem. See, more stars, especially those big ones that live fast and die young, should create a lot more dust. And dust acts like a kind of cosmic smog, right? It should make galaxies look redder and dimmer. But JWST is seeing these galaxies as intensely bright and often blue, which directly contradicts what other telescopes have been telling us. Okay, so with all the conventional explanations struggling, some scientists are thinking maybe we need something truly radical. An idea that comes from a completely different direction. What if the extra light we're seeing has nothing to do with stars? As physicist J.E. Jacok put it in his paper, the solution is probably related to some as yet undefined astrophysical factors in the early universe. Now, that's basically science speak for we might need some brand new physics to figure this out. And that new physics might be something called Fermi sphere decay. Now, it sounds complicated, I know, but the core idea is absolutely revolutionary. It's this proposed quantum process happening right at the edge of a black hole that can create a massive blast of light without a single star being involved. So this new theory completely recasts what black holes were doing in the early universe. They weren't just cosmic vacuum cleaners. They were cosmic spotlights, lighting up their surroundings in a way we never, ever imagined. So here's how it's supposed to work. First, a bunch of hydrogen gas falls toward the black hole. Next, as it gets super close, near a boundary called the photon sphere, some quantum weirdness kicks in and forces a massive release of energy. Then, this energy erupts as a blast of photons, shooting out in all directions. And here's the really brilliant part. That blast of light zaps the huge clouds of gas all throughout the galaxy, causing the gas itself to glow super brightly, basically faking the light of billions of stars that aren't even there. And just like that, this one single theory could solve both mysteries at once. It explains all that extra brightness without needing an impossible number of stars, and it totally sidesteps the dust problem because you're not actually making any new dust. It's just an explanation that fits all the clues perfectly.
Which really leaves us with this final, profound question. For decades, we've pictured the first galaxies as these cosmic lighthouses, powered by stars. But what if they were actually spotlights, powered by black holes? If that's true, what else about the dawn of our universe have we been looking at in a completely new and maybe even misleading light? It's a fundamental shift in how we see our own cosmic history. Thanks for diving in with us to explore it.